On stage, another fireside chat for you, talking about Fly with AI, harnessing enterprise to launch dozens of AI projects. Please welcome on stage Adam Bonnifield, VP of Artificial Intelligence at Airbus. He'll be interviewed by Ted Shelton, Chief Customer Officer at Catalytic. Please give him a warm round of applause. Thank you.
All right. Well, I've noticed that you guys have a lot of really good questions, which I'm glad to hear. So we'll be making sure that we make time for you guys to ask questions. But we're also going to ask you a few questions, which in the initial phases here, we'll just ask you to answer by a show of hands. So the first question I want to start with for you is just to get a sense of the audience. I'd like to know, because Adam is with a very large company that makes very large airplanes. I'm from a very small company that makes small, well, we don't make airplanes at all, we make software. The audience, I think, probably is a mix, and I'd like to know how many are on sort of my side, a small company, how many are Adam's side, a big company. So small company hands?
Oh, wow.
Oh, okay. They're all on the, okay, could you guys, a couple of you move over there? And
it's like a wedding, you know, guys.
Yeah. Big company? Okay, all right.
Family of the groom.
So it's actually about half and half.
Okay, good.
All right. Well, let's hear a little bit about your big company. What's going on there with AI, and how long have you guys been working on this?
Yeah, so that's the funny thing. I mean, I remember from the introduction, we heard that, you know, a lot of companies are just starting to experiment with AI. But in Airbus's case, this has been a journey for decades. You know, for those of you who don't know, we design, engineer, manufacture, and service aircrafts and helicopters, but then also have this massive defense and space business where we're operating satellites and taking tons of imagery of the planet. And so there's just tons of different sort of first generation AI projects in that. There's automation and autonomy in the manufacturing and aircraft business, and then there's a lot of early stage computer vision image processing projects that we've done with all this amazing satellite imagery. So to some extent, we have the battle scars and also the lessons, the positive lessons of experimenting with these technologies for quite some time. But what's been revolutionary is, I think, what every company's been experiencing in the last several years, which is that all of a sudden now, the price of using these technologies has plummeted because of the explosion of computing power availability and the decrease in price. And in Airbus's case, we've made giant investments in digitally transforming the company, which has meant that it's possible to apply all these fancy algorithms to all these different projects that were previously impossible, and made a massive investment in connecting all of our enterprise data together in a massive data platform called Skywise, where we've taken sensor data from our aircrafts, industrial data from our manufacturing process, and other operational data that we use to service the planes and maintain them, and brought it into one environment. So we kind of set the scene for this shift from approaching the problem as what are kind of problems in our business that present themselves as AI problems, into a sort of posture where we sort of say, forget that, let's just look at the big problems and use AI to solve them. And so the wow realization for us was that we can take some of the biggest problems in our industry and have ambitions to just solve them, period, using some of these technologies. So to literally eliminate grounded aircrafts, to eliminate quality nonconformity problems that happen downstream, and to solve the problem of operational delays, so to literally never have another delayed aircraft, or at least to solve the problem of chronic delays in aircraft. So but all of that was possible because we realized there were these sort of totemic shifts in sort of what's been happening in all the private sector experimentation, and then also B, investments we made years ago that have sort of set the stage for today.
So for those of you keeping track at home, that was the wow. Because actually it is a wow, right? I mean, you're going to increase airline efficiency and airline profits if you never have a grounded aircraft and you eliminate this challenge of getting the plane off the gate. And of course, you're going to increase traveler satisfaction, right? So,
yeah, so about $40 billion is spent on delays in the United States. So it's a very, very big problem. And it's a solvable problem. I mean, to me, that's the sort of revolution in some of these AI applications that, you kind of realize that they're actually not that complicated once you kind of break it down into an analytic problem. And so for us, when we were looking at this and we were sort of looking at sort of how the market performs in all these different airlines, realized that kind of about 80% of airlines are chronically late, which is a funny number because it means 20% actually aren't. And the vast majority are, which is what creates the massive problem. So what are the 20% doing that the 80% aren't? And so we started to study the variance of the 80% and realized that actually it's just because they don't have access to certain data that would help them manage a lot of the normal problems that happen when your plane lands and then before it takes off. And so if you can use AI to kind of surface that analytic data, then you could literally eliminate the problem in the first place.
So one of the things that you and I talked about before coming up on stage, though, which really appealed to me as a startup guy in my half of the room, was the way you go about taking that AI question and solving it. You, of course, have some fantastic resources internally, but you were mentioning something you're doing with sort of ecosystem approaches.
Yeah, exactly. So for the family of the bride, all the startup people, I think what I often realize, because I also was a kind of entrepreneur myself, is you get trapped in this kind of valley of death where companies love to kind of bring you in and have you do projects that kind of are interesting experiments but don't actually ever get industrialized. And this is more or less the pattern. And at least we see this as a problem that we have to solve in Airbus, that it's too hard to get inside the door of big companies. And once you're in, you don't get enough support to actually apply your problems to real kind of industrial scale, which is the whole point of working with a company like Airbus. And so realizing this, we sort of looked at the kind of underlying dynamic and realized that actually this is a huge problem for Airbus because a lot of the best companies to work with are small ones. We see ourselves as domain experts, but domain experts in part of the problem. And then the other part, we're not going to be able to solve as well as the sort of sum total of all the startups out there. So working with startups is really great. And then the problem is just kind of surfacing the best ones. So we built a platform called AI Gym, which is at aigym.airbus.com.
Is it AIGYM?
Yes.
.airbus.com?
I believe so.
Okay, just in case anyone's writing these down, I am.
Yeah. Where we're just sort of putting out problem statements that we're interested in solving and including the data and things like that. And then inviting startups from the ecosystem to experiment. And there are just a lot of these sub-problems out there. And this is the funny thing that, when I meet a lot of startups in different venues like this, I often talk to them, and because we're still in this emergent stage, a lot of startups, I would say, are still trying to figure out what is their play to work with big companies. And at the same time, we kind of know the problems that we want these companies to work on. And so I really think it's just a marketing problem. We need to do a better job of saying, here's the 4 problems that we would love it if one of you guys could figure out how to solve for us. And the exciting thing is it's not just us, it's a bunch of companies in our space. So for example, if you think about NLP and knowledge extraction, we need help understanding how to extract knowledge from technical diagrams that have a lot of visuals and a lot of captions and annotations. If you guys can help us solve that, you'll make a lot of money. And yet, this is a problem that it's hard to find companies who are working on it. There's some NLP problems that have kind of risen to the level of sort of the consciousness of the startup community, and there's other problems where we're pulling our hair out and we just want startups out there to work on. And so we're trying to do a better job of surfacing those and then actually working on industrializing them once we sort of get some engagement with startups. So we had almost 100 companies come in and many industrialized projects that have come out of this kind of experimentation. And what's exciting is the companies that end up performing the best are often small ones that we would have never discovered otherwise.
Well, I want to roll back to something you said a little bit earlier about having had the discipline to pull together all this data. And you said it was in, what did you call this space that all this data is in?
Oh, Skywise.
Skywise, so
Yes.
not Skynet.
Yeah,
it's
an interestingly named platform.
But I get it, sort of an aeronautical reference there,
Exactly.
Skywise.
Yes.
And I think this is an enormous challenge. In fact, actually, I'd like to ask my second question of the audience here. By a show of hands, I'd like to know how many of you feel like your companies are being held back by not having a sufficient amount of data available or organized. It could be a startup with, is there enough data to solve the problems we want to solve, or it could be a big company saying, have we got the discipline that Airbus is talking about? So show of hands, how many do not? Okay, actually, people seem to be doing pretty well in this audience. And this is probably an outlier audience, to be sure. But any particular notes you would make about sort of the availability of data? Important, sir?
Yeah, I think there's this. There's definitely this movement, obviously, to move data into a data lake, and that has to do with, I think, just trends around cloud computing and an understanding that the data is useful together. I think the key lesson we learned, which was sort of the aha moment for us, was that bringing the data together is only solving the first part of the problem, and then the second part of the problem, especially to make it useful for AI applications, is understanding how that data interoperates under a kind of single analytical framework. And just as an example, to take a kind of predictive maintenance problem, because this is a problem that you see across basically every industrial domain, and there's sort of an assumption, sort of like put a bunch of data into a fancy model and then output, when will my component fail and what should I do about it? Like, what was the root cause of it? And in reality, it's a tough problem to solve because none of the data was really meant to be shared as part of one analytical model. In our company, we have engineers, and if you ask them how to predict when a part will fail, they'll give you a model based on the sort of theoretical design of the plane. If you ask flight operations people, they'll be interested in data about the service history of the plane, what kind of conditions it was subjected to, what was the weather and the impact of that on the actual performance of the part. And then, of course, if you ask sort of people who deal with servicing the part, they'd be very fixated on kind of when do we have a replacement, when can we get it to the plane that needs it. So, I mean, and they'll give you three separate answers, and what it sort of reveals is that they all can't be right if they're saying three different things, and yet each of their explanations is perfectly internally consistent. And so for us, the challenge statement is then to sort of integrate not just the data but the analytical approaches, which is why they arrive at the different answers, into a single common analytical framework, which then allows you to have a kind of objective function that you could optimize against. And until you do that work, it's kind of a fruitless exercise to have a lot of these fancy AI systems. So that project, which is kind of enabling the company with some real intelligence, is to us a precursor to actually work on some of this sort of artificial intelligence. And it's something that I think a lot of companies are eager to skip past. But it's literally the foundations of all of our AI-enabled projects.
So if I was going to sort of summarize that, if it's not enough to just have collected the data, but in order to prevent bias as you're moving forward and trying to make sense of the data, you also have to say, well, what was the sort of the set of assumptions that went into why this particular data was collected in the way it was collected, which is then ultimately going to result in a bias if I was to take it in the abstract, right?
Exactly right, and in the sense, it's not a purely academic exercise. The way you arrive at that answer is by forcing the engineer and flight ops people and services people to come up with a common approach to a comprehensive set of this data. So you can acknowledge the bias, but the way you remove it is by forcing all these different parts of the company that are used to thinking about these problems inside their own silos to integrate not just their data, but their approach to the problem itself.
One of the interesting examples we talked about was studying boarding processes and the evolution you went through and the way in which you collect data, and then the use of AI to be able to make sense of the data you're collecting.
Yeah. And this is, I mean, this is kind of another aha moment for us because I think when people think about the value of a lot of these AI systems, they think of it purely as kind of taking a high-performing statistical model and then using a machine learning approach that's like 2% more performant. And from our perspective, I mean, those are interesting use cases, but the really cool ones are more where there really wasn't a solution to the problem previously. And that by using some of these AI technologies, we can create visibility and create new forms of data where none existed. And so when we think of our most exciting projects, they're often following that formula. In the case of operational delays on planes, part of the reason that we couldn't solve it wasn't because we couldn't quite optimize all the factors, it's because we literally didn't know what was happening around the plane. And so the AI use case was installing cameras around the plane just to be able to translate video of what's happening into the plane into time-stamped data points. Or to take sensor data coming from the plane and make inferences about, based on the pitch of the plane and certain vibrations that are that are detectable, you can actually predict when, for example, people have started boarding. So these kinds of inferences are really just generating new forms of data. And once you do the analysis of the data, it becomes a much simpler exercise. But in our view, the real groundbreaking advancements have to do with discovering data that previously did not exist, which then allows you to solve previously unsolvable problems.
So I'm going to ask my question again. Now that we're trying to level set it, what it means to have your data organized. And what it means is you have to have cameras around your airplanes and be sensing vibrations. Do you guys now all still feel like you've got all your data organized?
But this is one of the things about being an industrial company that we deal with this stuff that it's quite fun, but it's a whole nother level of challenge to not just solve the problem analytically, but then to deal with a sort of industrial operating environment, which creates tons more complexity.
Mm-hmm. The insights that you're able to gain from this data, all the data you're gathering and analyzing, are you using that data to drive decision making directly, or is there some interaction with people on the ground that is there still a human role in all of this? Are we done as a species? What's next?
Okay, am I qualified to say if we're done as a species? I think that there's a lot of sort of science fiction phobia around AI that really, at least in my view, misstates how the technology is really being applied. When we at Airbus think about mature use cases for AI, we focus on narrow intelligences as opposed to general intelligences. So we think about vision, conversational assistance, detecting anomalies, or extracting knowledge from unstructured data. And in that sense, these technologies are really never meant to be displacing people. They're solving part of a problem that people can then use to become more expert at the tasks they're undertaking. And this is something that I wish was more often stated in conferences like this, that really the question we should be asking is not how to protect people from these technologies, but how to deliver them to people to make their jobs a more fun, empowering activity. Basically, all of our use cases, because we come from this advanced industrial company, we're lucky to say that they're geared towards taking our experts and allowing them to spend more of their day doing those expert tasks by arming them with new data. And this is, I think, a very positive vision of this technology landscape, because it is designed to make the things people do more and more fulfilling and impactful.
So I want to take a couple of questions from all of you. Do wait for a microphone to come around before you ask the question, because one up here with the gentleman in the blue shirt. And we'll see. I actually really liked a bunch of the questions you guys asked in the previous session, so I'm holding you to a high bar now.
Adam, very quick two-part question. Thank you for your insights. First is, you explained your NLP use case with engineering drawings, with heavy annotations. You said that people can make a lot of money if they understand how to address that use case. What is keeping ambitious startups from hearing you and doing it? Is the problem not sexy enough, or is it too complicated for them to address?
I really just think we are currently in an emergent, a period of intense experimentation in the private sector, where this technology is still immature, and it's literally just a matter of discovering all these different use cases, and then being given a context to work in them, where they can scale an industrial application. Okay. In general, industrial enterprises are late to the game, and so they're not providing the right starting point for these companies, and often don't even have the right processes to engage them. I mean, for us, we needed to change how we do our contracts, how we do our procurement, just to be able to bring a small company into our space within a 3-month period, to be able to get their hands on real data. So that's the problem we're just trying to accelerate. It's going to happen either way, and there's many of these sub-problems, but we have to help make it happen faster if we want to take advantage of these experiments first, basically.
All right, second part, very quick. This summer, I mentored a team at Techstars that was focused on counterfeit aircraft parts.
Right.
Now, it's one thing to get a counterfeit Louis Vuitton bag, but when you have counterfeit airplane parts, you've got 250, 300 souls at risk. And they were taking a blockchain, supply chain focus. Is AI able to help solve this problem?
Yeah, so there's definitely computer vision applications that are very good at it, actually, that basically are good at establishing a visual signature to parts. So that's just one obvious example of that. And there's big companies working, I won't say which ones, but there are big companies that are working on this exact problem. There are some challenges in the industrial manufacturing process doing that, because it relies on taking a very good high-resolution picture of the part. But yeah, so suffice to say, yes, it's a solvable problem. That's a use case that's been identified and in production today.
People are working on that. You'll benefit from that. You're in the engine manufacturing, you'll benefit from that.
Exactly. Yeah.
Do you have another question out there? Well, no, thank you, but.
I'm not sure. Hey, over here.
Yeah, thank you.
Phil Cooper with Salesforce. So I'm curious what your business model will be when you deliver productionalized output of these AI solutions that you're building to the end customer, or not the end customer, your customer. So what's the business model if you manage to do predictive maintenance, or if you give them an onboarding solution that optimizes how they manage that? How does United or Virgin or whomever take that?
Yeah. So in our case, as you say, our customer are airlines, which is sometimes counterintuitive, or just people don't often think it through. So for us, our job is to essentially take data that often comes from these airlines, anonymized, and combine it with the data that we have about a lot of these different domains, which are often useful in answering these problems, and generate interesting applications. So our approach to the problem is essentially, come join the party, participate in this broad data platform, on the theory that in the long term, you will do much better sharing your data in a kind of healthy, rich, comprehensive data platform. And be able to kind of take part in the benefits of it. So in that sense, I mean, we have a fairly straightforward business model, but the theory behind it is really that we're asking our sort of shared corporate community to all sort of go along on this journey together, and then doing the best we can to produce interesting applications that come from the data that we're collecting.
Yeah, it's a terrific ecosystem approach. There's a gentleman up here with a yellow shirt that has a question. I think it's a yellow shirt.
It is. Thanks. My wife's favorite color. All right. Can you comment on how AI innovation is being managed across the enterprise? Do you have a separate department driving this? How do you encourage people to come out with ideas? How do you rank them by ROI and so on?
Yeah,
So
yeah.
what's your innovation model?
It's a great question. I think something that, Airbus is a traditional company, right? So we're used to, decades-long roadmaps, if you think about our products and the way they evolve. And yet that has nothing to do with how digital innovation works, right? The domain will be reinvented in the next 10 years. The technologies and tools that we use in next year, a few years from now, will be completely different than the ones we're using today. And so there's tremendous number of changes that we need to make in order even just to keep pace with the pace of innovation that's happening outside of our company. And so we see two roles. We see the first role as having a specialized team working on that problem, which is how do we transform the company to be able to capture the benefits of these technologies. And that involves hiring data scientists and engineers and people like that. But that team can't be the permanent answer to the problem. If you believe as we do that essentially there are no AI problems, there's just big problems that AI can solve, then the business needs to be empowered to solve those problems. And so our theory is that our job is not to solve the problems, our job is to transform the company in order to empower the business to solve the problems themselves. So, I mean, that's a short answer to the question. I think in our view, you kind of then get into a thesis of what does this technology look like and how will it evolve? And again, we believe it to be a ubiquitous technology, so we're planning for a future where every line of business is working on AI problems as we move forward.
Thank you.
Thanks, and that's all the time we have. Thanks for being a great audience.
Excellent, thank you. Fascinating stuff. We are at my favorite part of the event, which is where we get to go outside and have some drinks and have some nibbles. Thank you so much all for being here today. We've just got a couple of announcements quickly. So yes, you have the cocktails outside. Thank you so much to WorldPay for sponsoring those. Don't forget Chatbox as well. You should be downloading Chatbox. It should be asking you little questions at the end of each session. We need that feedback, so thank you very much for doing that. And then we have added in a wonderful after party for you. So after the reception, please head down to Sam's Anchor Cafe in Tiburon. It's at 7:30 p.m. and we'll all see you there. If we don't see you there, I'm sure we'll see you tomorrow. Thank you so much for a wonderful day one, and we'll see you again tomorrow. Thank you.